Hello. So we are continuing our work on circles, and last time we looked at the equation of a circle, which, as a reminder, was this: x minus a squared plus y minus b squared equals r squared, where AB was the centre and r was the radius, right? Okay, in this section then, what we're going to then consider and why it was useful to work out the equation of a circle is that now we have an explicit equation for it, so we can then consider what happens when we intersect, say, a line and a circle. So we're going to have this situation where then we have y is mx plus c, a line intersects this circle here, and so actually what that happens is these form simultaneous equations if I call this equation 1 and equation 2, and more particularly these are quadratic simultaneous equations, right? If I expanded these brackets I'll get x squared and y squared. That's a quadratic, right? And I could substitute the line into the equation of the circle. Okay, and we discussed this when we looked at quadratic simultaneous equations. When we will get a quadratic when we do that, and then we saw that the quadratic has a discriminant, right? And so the number of solutions to that simultaneous equations, if there's 1, 2 or none, corresponds to the discriminant being greater than 0, equal to 0 or less than 0. And that's exactly the same idea. It's basically the same idea we looked at with quadratic simultaneous equations, but now in the context of a circle, okay? Because now we have this new formula for the equation of a circle which will help us. And so then obviously we're going to have three scenarios. Say you have a circle again here. If obviously a line can pass through a circle twice, so there and there, right? And that's two intersections, which means two distinct solutions, I may add. Now, if there's two distinct solutions, that means the quadratic we get from solving this would mean that the discriminant b squared minus 4ac would be greater than 0. Remember when we discussed that, when we looked at discriminants? If the discriminant is above 0, positive, that means we have two distinct real solutions, okay? So when we solve these simultaneous equations, 1 and 2, here and there, when we substitute one into the other, we get a quadratic, and the roots are determined by the discriminant, okay? Then we got the other case where we have the same circle, say, any given circle, but now we have a straight line where, if I can draw a circle, I'll take it there. There we are, where there's only one intersection there, okay? So we have one intersection, perhaps, which means one distinct solution to the simultaneous equations. Therefore, actually I'm going to move this over here because I want to make room for the last diagram as well. So we would have one intersection, which means one distinct solution if we were to solve the simultaneous equation. Now, if there's one distinct solution, that means that the discriminant would equal 0 in this case, okay, when we get a quadratic. The last case then, well, then you might guess, is actually when it doesn't intersect at all, okay, so no intersections. So again, we have a circle here, and the line could be just absolutely no, it could be like just there or something like that, right? The line is, say, there, okay? And so in that case, there are no intersections, which means no real solutions. And therefore, because of that, the discriminant has to be negative, okay, so less than 0. Okay, so these are basically the that's basically what we looked at, right, with quadratic simultaneous equations. You get a quadratic, and then the discriminant will tell you how many solutions there are. That that solution corresponds to an intersection. Okay, so we have two distinct solutions means two intersections. And then if there's one intersection, that means there's one solution to the to the simultaneous equation. And obviously, no solutions means there's no intersections. Okay, so that's what's going on here. Okay, and in particular, this last case, this middle case, when a line has one intersection with a curve, what I can add to this that this line is a tangent to the circle at that point. Okay, and we call that touching the circle. Okay, so if it crosses at one point, it touches the circle. Okay, so when you see that the if a given line to a circle is a tangent to the circle, that means automatically it only intersects the circle once. Okay, and so therefore one solution, so the discriminant will be equal to 0. Okay, every tangent to the circle, remember a tangent line, remember, it's just a way of estimating the gradient at that point. So if we have a point here, say, the tangent would look a bit like that, rough thereabouts, and the gradient of the line will give you the gradient of the circle at that point, say. Okay, any tangent at any point on a circle, say there, or perhaps there, or there, or so on, any tangent whatsoever, there will only be one intersection with the circle. Okay, and that's a key property, which we'll be using in this section. Okay, so so again, just to recap that, a line which is a tangent will only have one intersection with the circle. Okay, so discriminant will be equal to 0. Okay, now I did say last section as well, it was very important to be able to work out the equation of a circle because it comes up all the time. That's the most important part of this topic. This video is going to be the second most important topic, so you do not want to miss this either. This idea of what we're going to do with intersections of lines, because it comes up quite a lot and a lot of marks as well. So yeah, let's have a look at some examples then. Example 8, find the coordinates of the points where the line y is x plus 5 meets the circle x squared and y minus 2 squared is 29. Okay, well then we need, when they meet the circle, they intersect, so we need to equate them together. So firstly, x squared plus y minus 2 squared is 29. That's equation 1. And at y is x plus 5. Okay, that's equation 2. So again, these two curves, they meet, they intersect. Okay, so we're considering when they intersect, so we have to equate them together, which means they are simultaneous equations. So what I mean by then equating them, I'm going to substitute y, the second equation, into y here in the first equation, and that's going to be the strategy. Okay, so I'm going to say sub y into 1, or you could say sub 2, it doesn't matter. I'm going to substitute the second equation then, so into the first one, so we have x squared, add y, now y then would be x plus 5 here, or x plus 5, then minus 2 all squared. Okay, because then we have a minus 2 after the y there. Okay, that's equal to 29. At this point then, well, before we expand it, let's just work this, simplify inside the bracket here. We have x squared, add x plus 5 minus 2 be plus 3 all squared. And then I'm going to move the 29 to the other side to equal 0, because I'm going to get a quadratic and I want it to equal 0. Okay, then we just need to expand it, so that x squared and then x plus 3, because squared is the same bracket twice. Then we expand it to get x squared, add x to x squared, right? Then x times 3 is 3x, times another 3x is 6x, plus 3 squared is 9, minus 29 equals 0. Okay, but then we can collect the terms together, so we have 2x squared, add 6x, 9 minus 29 would get me minus 20 equals 0. Okay, I could divide it then if I wanted to simplify it just a little bit, to divide by 2 to get rid of the coefficient on the x squared there to get just x squared plus 3x minus 10 equals 0. Can I factorise then? I want to practice my factorising skills, right? So remember, factorising, obviously you can do this on the calculator, but I'm just practicing my skills. So I want to then find two numbers at times to get minus 10 and add to get positive 3. There and there, right? Now, consider to work that out. Just consider the factors of 10. Okay, ignore any negatives. Just consider 10. So you either got 10 or 1. Does that add or take away to get 3? No. What about then 5 and 2? Yes, because I can recognise 5 take away 2 gets me 3. So I get some way of getting to 3 there. Okay, well then I need the times to get negative 10. So one of them has to be negative, the 5 or the 2. But I need to add to get positive 3. So the lower number needs to be negative there. Because then 5 take away 2 would be 3. And then they times to get minus 10. So that's my factors. So x plus 5, x minus 2 equals 0. Therefore, x is minus 5 or x equals 2. Those are my two solutions then. But those are my x. That's my x solution. So I need to find the y solutions, okay, to these. So that to do that, then I can just substitute these x values into into this equation here. Okay, why would I not want to substitute it into this equation? Because y would also be a quadratic. Okay, so if I have a quadratic then for y, that might give me two solutions. Okay, but if I only want one solution for y for each value of x. Okay, so always substitute it into the linear equation in a quadratic simultaneous equations. Okay, so substitute it into this equation, y is x plus 5. So sub x into y is x plus 5. Therefore, if x is minus 5, then y would be minus 5 plus 5, that would equal 0. Or if x is 2, y would be x, which would be 2 plus 5, that would be 7. Okay. Therefore, then, what did it say? To find the coordinates of the point where the line meets the circle. Well, that's just our solutions then. So the points are either x is minus 5, y is 0, or we have x is 2, y is 7, and there we are. Okay. So yeah, so that's just simultaneous equations, right? A bit more of a step up because you got more awkward brackets because of how the equation is. You get two squared brackets, but the idea is the same with simultaneous equations, right? That we looked at earlier in the course. In the idea, we're going to substitute the line or one equation to the other, and then solve that equation to get the values, and then substitute it back in to get the other values, and there we are. Cool. Let's have a look at this example then. Show that the line y is x minus 7 does not meet the circle of that equation. So let's note that down. X plus 2 squared plus y squared is 33. And y is x minus 7. Okay, now we want to show it does not meet the circle. In other words, does not intersect. Well, if we want to consider their intersection, again, we need to equate them together. So they need to be simultaneous. Okay, so again, call this equation 1 and 2. Then again, I'm going to substitute y into the circle equation. So I'm going to say sub 2 into 1 now. I could say sub y in. It doesn't really matter. They're not that fussy. All in all, then if I substitute y here into the first equation there, I get x plus 2 all squared plus y. Now y squared, my y would be x minus 7 all squared, and then I'm going to move the 33 to the other side to get equal to 0. Okay, now I just need to expand these brackets. So at this point, I'm just going to do it in one go. We did look at expanding brackets at the start of the course. Hopefully, I think this is a good exercise to test your expanding skill, brackets knowledge. But yes, so let me jump into it then. X plus 2, if that would go to x squared, and then times 2x plus another 2x would be 4x, and then 2 times 2 would be 4. Okay. Then for this bracket, I'm going to have plus x times x squared. X times minus 7 is minus 7. X times a minus 7 will be minus 14x. Okay. Then minus 7 times minus 7 will be plus 49. Okay. minus 33 equals 0. And yeah, if you are still struggling in the brackets, remember you can do it off to the side somewhere. Say if I did it like that, and then you could just expand it the way you do, right? So that would be x squared plus 2x plus another 2x be 4x plus 4. Okay. But hopefully when you get really used to it, like I have, you do start to be able to expand more simpler, should I say, brackets fairly quickly. Anyway, we get that then. Then we can just collect all the terms together. So x squared, then another x squared would be 2x squared. Then we have a 4x and a minus 14x, that'd be minus 10x. Then I have a plus 4 plus 49 and a minus 33. Well, 4 plus 49 minus 33 gets me plus 20 equals 0. Again, let me just simplify it. I don't have to, you can put it in the calculator at this point. But Bob, what I mean by putting the calculator, do not, I don't recommend just pulling it into your quadratic equation solver function in your calculator. I mean, do like write down the quadratic formula to show you're working, and then you can use your calculator to get the answer. Okay, the idea is I want to show my working, okay, at every step, to show how I get my solution. Anyway, so I might attempt by factorising again, I don't know. So divide by 2 just to simplify the equation. I get x squared minus 5x plus 10 equals 0. Then, again, if I want to factorise, I need the times to get positive 10 there, and add to get negative 5 there. To do that, let's consider the factors of 10. So 10 or 1, that won't add or take away to get 5, no way. What about 5 and 2? No way. 5 add 2 would be 7, 5 take away 2 would be 3. There's no way I'm going to get 5 from that. I think that's the factors, right? So I can't solve it by factorising. So at that point, yeah, let's just use the formula then. So x then would be minus 5 would be plus 5. Take plus or minus the square root of b squared minus 5 all squared. Take away 4 of a, which would be 1, c, 10, which are the coefficients, right, of the quadratic, over 2 of 1, and so put that in the calculator. Now, as I was saying just a moment ago, exam tip, so I've shown my working by writing down the formula to show how I get my solution. At that point, you don't have to write out the whole formula, the fraction. You can then just do the quadratic equation, solve a function in your calculator to get the roots quickly. But you've shown your working to the examiner, right? So if I do that on my calculator, I get the solutions. Well, I get a nasty root, right? So x would be I get this sort of the calculator says 2.5 plus or minus root 15 over 2i. Now, I did speak about this when we looked at quadratics. When you see this weird I and the equation looks weird, that I tells you there's no real solutions, okay? So there are no real solutions for x, therefore, there's no solutions to the equation, so they cannot meet the circle. So therefore, no real solutions, therefore, line does not meet with the circle, okay? Now, there is a lot cleaner and probably a quicker way I could verify that, and that's a discriminant, right? Alternatively, when we got to this quadratic, we could have then just worked out the discriminant, right? So if we did b squared minus 4ac, b squared would be minus 10 squared, minus 4 lots of a would be 2, and c would be 20. That would get me, if I put that in my calculator, 10 squared minus 4 of 2, 20, that's minus 60, okay, so that would be negative, so less than 0, therefore we can immediately conclude from that there's no real solutions, okay, so there are sort of two ways, right, but I think that's the more effective way, but I've shown both ways to see what you might, potentially what you might do, but yeah, both of those outcomes are perfectly fine. They both lead to the outcome that there are no real solutions. Therefore, the line cannot meet with the circle. Okay. There we are. Okay, let's have a look at some exercises then, some further examples. So this one, we are told the circle with equation x minus 4 squared and y plus 7 squared equals 50 meets the straight line with equation x minus y minus 5 equals 0 at points A and B. Find the coordinates of A and B. So first we're told that the circle, x minus 4 squared, y plus 7 squared equals 50. Meets the straight line, so intersects with the line x minus y minus 5 equals 0, okay? At points A and B, well, again, if we're considering where they intersect, we need to equate them together so they're simultaneous again. So solve them as we normally do, as we just did. Well, the second equation isn't exactly in the form y equals, so we need to rearrange it a little bit. So if I rearrange equation 2, I get that. Let me rearrange for x this time. So x would be y plus 5. Okay. Then I'm going to substitute this, right? I'm going to sub x into the circle equation, right? The equation 1. Then that will become, well, x minus 4 will now be y plus 5 minus 4 all squared. Now 5 plus minus 4 will be plus 1, okay, so that will go down to just plus 1 squared plus y plus 7 squared. And then going to move the 50 to equal 0 overall. And there we are. So now we just need to expand the brackets. So that will go to, if we expand it, well, y squared plus 1y plus 1y will be 2y. Plus y, 1 squared be 1. Then for the other bracket, we're going to have y squared again. Plus 7y, and then another 7y be 14y. Then 7 squared be 49. Minus 50 equals 0. Then if we collect all the terms together, y squared and y squared be 2y squared. Then 2y, 14y be 16y. Then we have 1 and 49 and 50. Well, that will go to 0, actually, so it just be equal to 0. Okay. But then we can solve this. Well, firstly, I can divide by 2 to simplify it a little bit to get y squared at 8y equals 0, and then I can factorise it, right? So then y of y plus 8, so y is common to both of them, equals 0. Therefore, if we set each factor, each part equal to 0, we're going to get y equals 0, or y plus 8 is 0, but then that would mean y would be minus 8. There we are, so we've got our solutions, right? But that's our solution for y. Then we need to find the corresponding x solution. But we know x is here, so we can use that, okay? So x is y plus 5, I believe. Yep. Therefore, when y is 0 then, first of all, then the x solution, the corresponding would be 0 add 5, which would be 5, okay? Then when y was minus 8, x would be minus 8 plus 5, that would be minus 3, okay? Substituting the y into there. Cool. So we've got our solutions then. So therefore, as coordinates, these 2 points would be well, x would be 5 firstly, then y would be 0, and we would have x would be minus 3, y would be minus 8, okay? So those are the coordinates. Now it said that the coordinates are points A and B, but I don't see how we know which one is A and B. They're not told us any information to distinguish, I don't think, between the points A and B to tell these 2 points apart. So I'm just going to leave it there, okay? I guess that's the solution part. Those are the 2 points or coordinates where the line meets with the circle, okay? So that's part A. Part B then says, find the equation of the perpendicular bisector of the line segment AB. So again, it's talking about a line segment AB. Let's visualise that to draw between the points, okay? So part B then. So say then you have a point A there, and then the point B there. That's line AB. Well, A, it doesn't matter what you pick. It won't matter at the end of the day. A, I'm going to say is 5, 0, and B is the other point then of minus 3, minus 8. Now, it's talking about the perpendicular bisector. Now, remember, it did work on this at the start of this chapter. The perpendicular bisector, first of all, well, it's a line that, well, bisector, it splits the line into half, equal parts, right? It bisects it. So it has to go through the middle, okay, to split it in half. So it's going to go through the midpoint, okay? This line here, and it's perpendicular. So it's going to be right angle, okay? So perpendicular gradient, right? So, first of all, okay. First of all, we're going to need the midpoint, okay? Midpoint M. So the midpoint between A and B, well, that's going to be added, firstly adding the X values together, a 5 take away 3, and then over 2. Then we add the Y values, so that's going to be 0, 0, add minus 8, and then over 2 values, over 2. Then that goes to 2. 5 minus 3 will be 2, over 2 be 1. Then 0 take away 8 be minus 8, over 2 that be minus 4. Cool, so we've got this midpoint here of 1 minus 4. Next, the other information we have is that it's perpendicular, the bisector. So we need to find a gradient of AB. So MAB is the gradient. So then how do we find gradient? Remember, it's changing Y over changing X of the two coordinates. So that will go to, well, first of all, let's take B first. So the Y coordinate of B is minus 8. Then the change, so take away the Y coordinate A, be minus 0. Then we do the same for X at B. X is minus 3. Then take away the X at A, be minus 5. That will go to minus 8. Oh, I can't draw an 8. Minus 8 over minus 3 minus 5 is minus 8. But that's just positive 1 then. Okay. There we are. So that's our gradient AB. Therefore, then, the gradient of bisector is, well, it's perpendicular, right? So remember, perpendicular, we do the negative reciprocal. So negative 1, but then if we flip 1, well, that's just 1 again, okay? Because this is same as 1 over 1. If you flip that, you still get 1 over 1. So that's our gradient, okay? And remember, you can verify your answer, because with two perpendicular gradients, they multiply to get minus 1. So 1 times minus 1 there indeed gets us minus 1. Okay, cool. But now we got, then we know the line has to be in the form y is mx plus c. That's any line, right? But we know the gradient now is going to be therefore y is minus x plus c, because y would be m would be minus 1. Okay, well now we just need to find that c. Okay. Well, that's why we worked at the midpoint, because now we have a line on the circle, on the line, a point on the line that we can substitute into this equation here. So then I'm going to say sub 1 minus 4 into the line. I then get, well, y would be minus 4, and then minus x would be minus 1 plus c. Therefore, minus, well, that would be minus 1, so therefore c would be minus 3, okay, if we add 1 to both sides, okay. Cool, so therefore at the end, therefore y is minus x minus 3, and there's my equation, cool, of the bisector. So remember how to do that, right? We looked at that, we looked at how to work out perpendicular bisectors at the start of the chapter. The idea is that of a line, you want to find the midpoint, which is where obviously it bisects, so it splits the line in half. That midpoint would be on the bisector, and also the gradient would be perpendicular, as it's a perpendicular bisector. With those two, with that two information, the midpoint and the perpendicular gradient, you can work out the equation of the bisector. Okay, then part C says, show that the perpendicular bisector of AB, which we worked out, passes through the centre of the circle. Okay, but what is the centre of the circle? Well, we're given the equation of the circle. We know from the last section how to work that out. The centre then, if x is minus 4, the centre would be plus 4 for x and plus 7 for y would then be minus 7 for the centre. So therefore the centre is 4 minus 7. So that's what we're going to substitute into our equation, right? So sub the centre, which again was 4 minus 7, and we want to show that this centre, this point, does lie on the perpendicular bisector. Okay, so if we do that, that means that y would be minus 7 and minus x would be minus of 4 minus 3. Therefore minus 7 equals minus 7, and but that's correct, clearly. This equation is satisfied. So centre lies on the bisector, on the perpendicular bisector there. Okay, that we worked out in part B. Cool. And remember we looked at as well, because A and B lie on the circle, say if A is there and B is there, the line AB is actually the chord, well, a chord in the circle. Remember, a chord is just a line in the circle. We discussed that any perpendicular bisector of any chord, again here that we worked out, must pass through the centre. Okay, that's a key property of a circle theorem, right? To do with circles, right? Any perpendicular bisector of a chord must pass through the centre, which part C shows to be true. Okay, so there we are. Then part D, lastly. I'll probably do it up here actually. Find the area of triangle OAB. So again, when we got something geometric like this, best to sketch it. So OAB, well, that's the points O, A and B. Let's plot those 4 points in, okay? There's 3 points in, sorry. X and Y. Well, first the O, again, is the origin. That will be there. A, well, A actually, we found A and B in part A, right? That's the points. Well, again, it doesn't matter what point we take to be A or what point we take to be B, because at the end we need to plot both the points anyway. So really it doesn't matter what we pick to be A or B. Let's take A to be 5, 0. So that'd be 5 on the x-axis, right? There, that'll be A at 5, and that's O at the origin. Then lastly, B was minus 3, minus 8. So minus 3 on the x-axis would be there. Minus 8 would then make it like down there somewhere. Okay, so that'd be B of minus 3 minus 8. Cool. So then if we plot this, plot these points together, connect them, we get that triangle, and we need to work the area of this out. Right. Again, the area of a triangle is a half times. If I write this out, area is a half, let me get rid of this now, a half times base times height, and in this case the base at the bottom of the triangle would be that distance there, but we know that distance, it's from 0 to 5, right, because A is 5 there, so that's 5, but then the height, now height is the vertical height, so not that slanted height from B to O. That's a slanted height. The height is the vertical, or sometimes called the perpendicular height, which is literally the straight vertical point of the straight line vertical line that goes from the bottom, the base of the triangle, to the top. So it's going to go from the base to this point here, and that's the height we're interested in. Okay, that's the vertical height, we call it. Okay. Well, that height again. Well, isn't that just well, isn't that just going to be if we look at the coordinates again, isn't that height just going to be 8? Because if the y value is minus 8 at B and it's going up to 0, well then you're going up by 8. Okay, so that would be my height. Okay, therefore the area then is just going to be half times base of 5 times the height of 8. But then the calculator, you should get 20. And that'd be units squared again, say. But you don't have to be that specific. But there we are, cool. And remember, we looked at examples like this with triangles on a coordinate grid like this in chapter 5. We looked at straight lines. We looked at how we can plot points on the grid, connect them with a line, and then work out the average triangle by that. Okay, cool. There we are. Okay, question 10. We are given the line of equation y is kx intersects a circle. Intersects a circle with equation, well, that home thing there, at 2 distinct points. So again, it's talking about, I know there's a k there, but the whole idea is, again, it's talking about a line and the circle intersecting. So again, let me write down the equation for the circle. Well, the equation, well, not the exact equation that we know, but the equation they've given us: x squared minus 10x plus y squared minus 12y plus 57 equals 0. That'd be equation 1, and that's intersecting with the line y is kx, and that'd be the second one. So again, if they intersect, we want to equate the two equations together so they're simultaneous. Okay. So we want to substitute one into the other. Now, you might be thinking, well, this is a circle. I know I need to get it into standard form, meaning it needs to look like this: x minus a squared plus y minus b squared plus c equals r squared. And we saw last time we complete the square on the x and the y parts to deduce the circle, the centre, and the radius, and so on. But actually, in this case, that's not needed, because really all I'm doing is just substitute one equation into the other. I don't need to make the equation any more fancy. I just need to substitute one into the other. Okay, so this isn't needed in this particular case. It's unnecessary work. Okay, to substitute one to make this into the bracket form that we know. Okay, to complete the square in it. It's too much work. We don't need to do that. Okay, we just need to substitute the second equation into this top equation there. That's what we're going to do. Okay, so if y equals that, so I'm going to then say sub 2 into the equation 2 into equation 1. So if y is kx, then I'm going to get the top equation to be x squared minus 10x, then y squared be kx all squared minus 12y will be 12 lots of kx plus 57 equals 0. Okay, and that is a 57 there. So again, if we expand it, we get x squared minus 10x, then kx all squared will be k squared x squared. Remember your third law. If we have a bracket squared, you raise everything inside the bracket to the power, so it'd be k squared and x squared. Okay, then minus 12kx plus 57 equals 0. Can we simplify this a little bit? Let's put the I recognise this can be a quadratic for x, a quadratic of x. So let's firstly group the quadratic parts together. We have x squared here and k squared x squared there. So we're going to have x squared. Then I'm going to factorise to get 1 plus k squared, and you'll see why that will help in a moment. Then for the x parts, I have plus x of then minus 10 there, then minus 12k there. Okay. Then lastly, I have the number 57 equal to 0. Okay. So all I've done there again is just group the x squared terms together and group the x terms together. Okay, to make it a bit more clear, we've got a quadratic. Okay. Now, why is that useful? Well, we can't do anything more with this. We can't really solve it, perhaps, per se, because we have this unknown k there. Okay. But we don't need to solve it, really. All we need to know, all we're given, that there already is 2 distinct points of the intersection. There's 2 intersections. Well, what does that mean? If there's 2 distinct points or 2 distinct intersections, 2 solutions to the quadratic, right? That would mean b squared minus 4ac has to be above 0. And for part A, we need to get to this inequality, here. Well, this is an inequality, so that's going to help us. So again, we then need to consider the discriminant, okay, of this, and that is why I rearranged or grouped the terms together in this way, because now you can clearly spot what the x squared coefficient is, which is this, the x coefficient, which is this, and the c part, the number at the end, okay. So with that in mind then, we know that the discriminant has to be above positive, above 0, in order for there to be two distinct solutions. So then b squared, again that's the coefficient here, b, so minus 10 minus 12k all squared minus 4 lots of a, which would be 1 plus k squared, times by c, which is the number 57 at the end, and that's going to be greater than 0, okay. So again, this looks like a bit of a mess, so really we need to expand this then. So then we're going to have this it might be a bit of an awkward quadratic, right? An awkward bracket to expand. So let me do it separately here. So minus 12k minus 10 times minus 12k minus 10. That's going to, if I expand it, firstly 12 minus 12k times minus 12k would be plus 144k squared. Then minus 12k times minus 10 would be plus 120k. Then we're going to do the same for minus 10 here. Minus 10 times minus 12k would be another 120k. Then minus 10 times minus 10 would be plus 100. Okay, and we can simplify that to 144k squared plus 120 and 120 be 240. k add 100. So I can substitute that in then to then get that there for 144k squared plus 240k plus 100. Then I need to expand this. Well, firstly I can do I'm going to do minus 4 times 57. Okay, you might have a bit of a weird order to do it in, but let's do the numbers first. So 4 times 57, well, it's going to be minus 228 of 1 plus k squared, and that's again above 0. That would be 144k squared plus 240k plus 100. Then if I expand this, I get minus 228, and then minus 228k squared above 0. Okay, then if I collect the terms together, I get 144k squared, take away 228k squared, I get minus 84k squared, and then 240k, well that's just 240k on its own. Then I have 100, take away 228, that would be minus 128, greater than 0. Okay, cool. Okay, well then, let me look what it says. Okay, I need to get, well, it looks very similar. I get a quadratic in k, but have it greater than 0. But here, it's less than 0. The way I would have done that, we achieve that then, is to divide by a negative to flip the inequality. But what I noticed even more is that the coefficient of k squared is positive 21, okay? Here, at the moment, I've got minus 84. So what do I need to divide both sides of the inequality by to get to positive 81? So that's when I do minus 84 divided by 21. So that's minus 4. So that tells me I need to divide everything by minus 4. Okay. Okay, and so then divided by 4, minus 4 to everything. Minus 84 divided by minus 4 gets me positive 21. K squared. Then 240 divided by minus 4 gets me minus 60k, and then minus 128 divided by minus 4 gets me plus 32. Okay, and again, because we're divided by a negative there, we then need to reverse the inequality to that, and there we are. That's the inequality we get. Cool. B, then what's it say? Solve it, I imagine. Yeah, head to determine the range of possible values of k. So you need to solve this, and again, this is a quadratic inequality. And again, we looked at how to solve those in an earlier chapter. So firstly then, well, in order to solve a quadratic inequality like this, we need to sketch the quadratic graph of k, okay? But I don't know what the roots will be where it crosses the x-axis. So what we need to do is to do 21k squared. Well, we need to solve this equation as it's equal to 0, right? To find where it crosses the x-axis, right? Remember, we call those the critical values, okay? So the critical values in this case are when it's the roots of this quadratic. So 21k squared minus 60k plus 32 is equal to 0. Therefore, if we solve by the formula, say, then k would be plus 60 plus or minus the square root of minus 60 all squared minus 4 lots of 21 of 32 all over 2 times a, that'd be 2 lots of 21, and then put that in the calculator or just use the solver as a solver function at that point. You get 21 minus 60, 32. Okay, oh, okay, you get a nasty fraction. Round your answer to 2 decimal places. Okay. I'll tell you what. I'll write down the exact answer. So k is it gives me 30 plus or minus 2 root 57 over 21. Well, and then as a decimal to help me visualise exactly what that number is, that would either be 2.147. or 248, I guess, to 3 decimal places, or 0.7075. I'll give it there. Okay. It's just the decimal's a bit weird. Okay, so I'll leave it as that. So those are my 2 critical values again, which are the roots if we solve the equation. That allows me to then sketch the graph roughly. So again, it's a positive quadratic, so it's going to have a smiley shape, so it's going to go like that. And again, the 2 roots are 2.148 and 0.7, so the first one's going to be there and the second one's going to be there. So it's going to look like that. Okay, cool. So that's 0.7. No, that's 2.14, and that's 0.7 there. Okay, so now we've got our graph and we've got plotted our critical values, our roots. So now we need to look at our inequality up here in the box, and it has to be less than 0. So it has to be below the x-axis. So we want the part of the graph below the x-axis, right? So that's going to be this region there, right? So when y is negative. Okay, cool. So then that region then, well, it's marked between these 2 critical values, right? When it's 0.7 and 2.14. Okay, so then the range of values of k here then, well, firstly k has to be above the first root, I guess. So k has to be above 0.7. But to 2 decimal places, it's this 0.7095, so it'd be 0.71, okay, to 2 decimal places. And it has to also be less than the second root there. So k has to be less than 2.14, but to 2 decimal places, 2.148 goes to 2.15. Okay. Oh, there we are. To 2 dp. Okay, so that's our range of values then. So then to 2, well, not 2 decimal places. So therefore we can combine them into one inequality, because if k has to be above 0.71, 0.71 is the lower value for k, so 0.71 is less than k, but also the upper value for k, the upper bound is 2.15. So k is between these 2 numbers, and that is our inequality. Cool. Okay, what a question. Let's have a look at this one. We are told that the line with equation y is 4x minus 1 does not intersect the circle with equation x squared and 2x and y squared is equal to k. Find the range of possible values of k. Again, very similar situation. We have well, first we have the circle, x squared plus 2x plus y squared equals k. which is 1, and this line y is 4x minus 1 there. Okay, again, we're considering that their intersection, so we need to equate them together. Okay, so then we already have y here, so I can substitute that into the other equation. So sub y into equation 1. And again, we don't need to complete the square or make it in the form of a circle that we know. We're not interested in the centre, we just want to find the point of intersection. So we don't need to make the equation fancy, okay? Okay, we do that then, substitute it in the first one, we're going to get x squared and 2x. Then y squared, well, y is 4x minus 1, all squared, equal, and then we're going to take away k equal to 0 to get our equation. But at that point, again, we're just expanding, so we're getting x squared and 2x, then 4x minus 1, well, 4x times 4x will be plus 16x squared. Then 4x times minus 1 is minus 4, then another minus 4 will be minus 8x. Then we have minus 1 times minus 1 will be plus 1, minus k equals 0. Then we can collect the terms together. To simplify, we're going to get 17x squared and 16x there. Then we're going to get 2x minus 8x being minus 6x. Then we're going to have plus 1 minus k there equal to 0. And again, this is a quadratic at this form, at this point, right? That's the A part, 17. B part is minus 6, and the C is this number here. Now, K is just a number as well, so this whole thing is a number, okay? Even though K is an unknown, it is still just a number, okay? Anyway, we got to this point. Now, we are told the line does not intersect the circle. What does that mean? There's no intersections, so there's no solutions when they are equal to each other. That means that if there's no solutions, the discriminant of the quadratic has to be less than 0. Therefore, if we then do the discriminant here, b squared minus 4ac less than 0, so we get that, well, b squared would be minus 6, all squared, take away 4 of a was 17, then c would be 1 minus k, and that'd be less than 0, okay? Cool. Then we expanded to get 36. Then minus 4 times 17 gets me minus 68. And then 1 minus k less than 0. Then if I expand that one, I get 36 take away 68, then plus 68k less than 0, because minus k times minus 68 is plus 68k. Okay, well then I'm going to then move this number to the other side. So I have 36 minus 68 is minus 32. That means 68k has to be less than positive 32 if I add then 32 to both sides, okay? And that's 68k there, okay? Therefore, k is less than 32 over 68, okay? Does that simplify? It should do, right? Yes, k is less than 8 over 17, okay? And there we are. That's my range of possible values of k. Great. Okay, so let's have a look at some exam questions then. First of all then, we are given a circle in this form. And then again, very typically, we need to then find the radius, the centre and the radius. So if we have x squared and y squared plus 6kx minus 2ky plus 7 equals 0. Okay, well then firstly, to find the centre of the radius, I need to complete the square. So that's going to be then, if I group the x parts together, I have x squared and then the 6kx here. Then I have the y squared and then minus 2ky plus 7 equals 0. Then I complete the square on the x parts first. So we're going to get x, and then half of 6k is 3k all squared. Then minus 3k all squared, that's going to get me 9k squared, okay? Then then I complete the square on y, I'm going to add y, and then half of minus 2 is just minus k all squared. Then minus k squared plus 7 equals 0. Then I move the numbers to the other side. So x plus 3k all squared, add y minus k all squared. Then minus 9k squared minus k squared is minus 10k squared plus 7 equals 0. Then all that needs to go to the other side. So then I'm going to get that x plus 3k all squared, add y minus k all squared equals 10k squared minus 7. Okay, therefore in terms of k, the centre, well again, if it's plus 3k for x here, it's going to be minus 3k for x here at the centre. Then if it's minus k in the equation here, in the centre it's going to be plus k for y there. And the radius, well, radius squared is this, so the radius alone is going to be the root of that. And there we are. We can't simplify that anymore, so there we are. Okay. So yeah, it's fairly nasty. There's a k there, but remember, k is just k is a constant, meaning it's just another number. It's a placeholder for a number, essentially. So just treat the process as you normally would, okay? Don't get freaked out, there's a k there. Just do how you normally would. Okay, so then we are given the line with equation y is 2x minus 1 intersects the circle C at two distinct points. So again, it's a very similar situation. So the circle and this line here intersect. So if you write down the equation we just found, so that's the first equation, and then this line here is the second one. And again, it's talking about them intersecting. Okay, so we need to equate them together again. They need to be simultaneous. So I'm going to substitute one into the other. So I'm going to sub y into the first equation because y is there. Then I'm going to get that x plus 3 all squared. Add y. Now y would be 2x minus 1. And then it'd be minus k all squared. Then I'm going to move this to the other side again. Then I'm going to get plus 7 take away 10k squared equals 0 to get an equation, okay, to make it equal to 0. That's how we solve them. Okay, but then I need to expand these brackets, very nasty brackets, and again you'll see why now it's important to really be sharp on your sort of basic algebra skills. Okay, so this one's not too bad really, but again if you're a bit unsure, expand it manually to the side somewhere, and go from there. But this one, I think, well, I at least can be able to expand it as it is. So firstly, x times would be get x squared from this. Then x times 3k will be 3kx. And then another 3kx will be plus 6kx. And then we have 3k all squared. That'd be 9k squared. Then this one, okay, this one I am going to do aside, okay, because there's 3 terms here. So it's a very tricky bracket to just do, well, at least for me to do in your head. So we're going to get 2x minus 1 minus k. Then it's repeated. If I expand this then, okay, so we saw brackets like this, and again, when we looked at the expanding brackets topic at the start of the course, did that bit in the first chapter, so we should be able to do this, but again, to do it, let's take the first term here, and then multiply by every term in the other bracket there. So we're going to get 2x times 2x be plus 4x squared. Then 2x times minus 1 will be minus 2x. Then 2x times minus k will be minus 2kx. Then we do the same for the next term there, minus 1. Again, times it by everything in the other bracket. Minus 1 times 2x will be minus 2x. Then minus 1 times minus 1 will be plus 1. Then minus 1 times minus k will be plus k. Then lastly, we will get minus k there, the last term in the bracket, times by everything again in the other bracket. So then minus k times 2x will be minus 2kx. I need to squeeze this in, I reckon. Then minus k times minus 1 will be plus k. Then minus k times minus k will be plus k squared. It won't let me... Oh, there we are, nice. So that'd be plus k squared. So that's my expansion then. But I can simplify it again by collecting the like terms together. Well, I only have 4x squared here. That's the only x squared term. Then I have minus 2x. And then another minus 2x with minus 4x. Okay, but then I have minus 2kx. Then minus 2kx again. That'd be minus 4kx. Okay, then I have plus 1. That's the only actual number. Then I have plus k and another plus k plus 2k. I've dealt with the 2kx already. Then lastly I get plus k squared. Okay, so I grouped all the like terms together. So the like terms were x squared x. Then we had kx. Then we had the number 1. Then we had k, and then we had k squared. So I was grouping all these terms together. Okay, they're all different terms. Okay, but there we are. Okay, fairly evil bracket. But again, we did look at that, and hopefully you should be able to expand that if you take your time with it and understand what you're doing. There we are. So that's a simplified expansion. So that's what we need to expand. Let's substitute our result in then. So then we're going to get that bracket expanded would be then plus 4x squared, take away 4x, take away 4kx, plus 1, plus 2k, plus k squared. Oh, that's not a k squared. There we are. Then we need to add these numbers at the end. Plus 7 minus 10k squared equals 0. Oh man, there we are. Then we need to collect all the like terms again. Oh, wow. So you have an x squared here and an 4x squared there. That's the only x squared terms. That'd be 5x squared. Then here we have 6kx. You can then cancel it if you want to, I guess, to know that you've ticked it off, I guess. Then we have 6kx, then a minus 4kx. There's no other kx terms, so that'd be plus 2kx. Then we dealt with that bit. Then we have I would do k squared next in order, but then I have a 4. I want to collect all the x parts together first. So then we have minus 4x. There's no other x terms, so it's just minus 4x. Okay, then I'll collect it. So then we have 9k squared. Then we have another k squared. Then we take away 10k squared. Well, 9k squared of k squared is 10. Take away 10. That leaves us with 0. Okay, so those go away. Then we have plus 1 here. Then we have 2k there. Oh no, sorry, we have plus 1 and then a plus 7. So that'd be plus 8. Then we cancel that out. Then lastly we have this 2k there on its own. And that's equal to 0. There we are. So that's simplified. So that's again a quadratic in x squared. So that's 5 for A. B. Well, actually we can simplify this a bit more to 5x squared. Then we group the x terms together. So x lots of 2k minus 4 for x plus 8 plus 2k. And then hopefully you recognise the quadratic in x we get a is 5. The b coefficient is 2k minus 4. And then the number at the end is 8 plus 2k. Okay. Okay, there we go. That was gnarly. That was gnarly. But we got there. Now, we can't do anything more of that. So we need to probably consider the discriminant. But we're told it intersects at 2 distinct points. So again, that corresponds to there being 2 solutions, or real distinct solutions to the quadratic. What that means then, in terms of the discriminant, 2 distinct points means it has to be positive to give 2 distinct solutions. So there we are then. If we then do that, we get that b squared minus 4a, so it has to be greater than 0. Okay. Therefore, b squared be 2k minus 4 all squared. Take away 4 lots of a, which again was 5. And then c, which is the number here. 8 plus 2k has to be above 0. Okay, now we need to expand some more stuff. Okay, here we go. 2k minus 4. Okay, well, 2k all squared, firstly, would be 4k squared, if I expanded this. Then 2k times minus 4 will be minus 8k. Then another minus 8k will be minus 16k. Then minus 4 times minus 4 would be plus 16. Then we have minus 4 times 5 is 20 of 8 plus 2k greater than 0. Then we can expand that one to 4k squared minus 16k plus 16. Then minus 20 times 8 is minus 160. And then minus 20 times 2k being minus 40k greater than 0. Okay. Then I'm going to collect all the k terms together. So we have 4k squared. Then minus 16k minus 40k being minus 56k. Then plus 16 take away 160 gets me minus 144 greater than 0. Okay, can I simplify this anymore? Does 4 go into the other terms? 56 divided by 4 is 14. 144. Yes, I can divide by 4 to simplify it. Cool. So then that'd be k squared. Then minus 56 divided by 4 gets me minus 14. Okay, then minus 144 divided by 4 gets me minus 36 greater than 0. Okay, cool. So now this is a quadratic inequality, which again we should know how to solve. So we want to sketch this quadratic in K. To do that, I need to find the roots or the critical values, right? So the critical values then is when we solve it. So I'm going to just probably use the formula here, just to write it down. So K would be plus 14 plus or minus the square root of minus 14 all squared, minus 4 lots of 1 and then minus 36 all over 2 lots of A, so 2 lots of 1. So that would get me 7 plus or minus root 85. Okay. Okay. So as a decimal then, if it helps, it's either going to be 16.22 or minus 2.22 to 2 dp. Okay. Just to help you sketch where roughly where the two roots would be when we sketch the graph. Okay, cool. So then we can sketch our graph. So we know what our values are. So that's going to be at minus 2 be there. 16, oh boy, 16 will be all the way there somewhere. So if we sketch our graph, it's going to look like this. And again, it's a positive quadratic. So we're going to have that sort of shape. So there we are. There we are. That's our graph. So again, that's going to be 16.2, and that's going to be minus 2.2 there. And that's K. So again, I want the inequality I got is here. I want it to be greater than 0. So that again means it needs to be above the k-axis or the x-axis, right? So it needs to be upwards. So it needs to be there or there again. If we were to continue this, there. Okay. So it has to be on the left side or the right side of the roots. Okay. Again, then, if we want these two regions, the left region, it needs to be less than this root here. So that means k has to be less than. Well, this corresponds to 7 minus root 85 there. Okay, or k. Well, for the second region instead, k has to be above or greater than this other root there. So that's the positive one. So that's going to be when k is greater than 7 plus root 85 there. Okay. Another note is that questions again might also specify the line is a tangent. Now remember at the very start of this session, a tangent was a special type of line where it intersected once to the circle. Okay. So tangent, say there, intersected the circle at one point and it's there, right? Every tangent to the circle will only cross it once and it touches the circle, as we say. Okay, but let's have a look with that then. So again, the first question is to find the coordinates of the centre and the radius again. Very standard now. x squared plus y squared minus 10x plus 4y plus 11 equals 0. Okay, well, so then we need to complete the square. So let's group the x parts together. 10x, it's x squared minus 10x, and then the y part, so y squared plus 4y, then plus 11 equals 0. Then we complete the square on the x part. X and then half of minus 10 is minus 5 all squared, then minus 25. Then we do the same for y, so y and half of 4 is 2, all squared, take away 4, plus 11 equals 0. Then we put the brackets together. Then we add the numbers, so minus 25 minus 4 add 11 gets me minus 18, but I'm going to equal it to 18 instead, and there we are. Cool. So that therefore means the centre, well, if it's minus 5 here, it's going to be plus 5 there, then plus 2 will go to minus 2 there, and the radius, well, radius squared is 18, so the radius alone is root 18, and that actually goes to 3 root 2 to simplify it. There we are. Cool. So that's part A. Nice, and that's 4 marks. Nice. Then we are told the line L with the equation y is equal to 3x plus k is a tangent. That means if it's a tangent, there's one intersection. Okay. So again, that's asking us to consider the intersection. So let's put the two equations together. Again, so that's going to be equation 1 and that's going to be equation 2. Right, again then, if we want to consider their intersection, we need to equate them together. So I'm going to substitute this y here into the other equation 1. Then we're going to get that, well, x minus 5 squared. Then add y. Now y would be 3x plus k. But then it'd be 3 and then plus 2 there as well. Okay. And I'd be, and then I'm going to move the 18 to the left again to equal 0. Now again, it's just expanding. Okay, so firstly, then if expanded, x minus 5 squared be, well, x squared, then minus 5x minus 5x would be minus 10x. Then minus 5 squared be plus 25. Then we need to expand this. So again, this is a nasty bracket. What I'm going to do then is I'm going to do that over up here. So 3x plus k plus 2 times by itself. And so again, the strategy is let's times it 3x by f on the other bracket. So 3x times 3x is 9x squared. Then we have 3x times k be 3kx. Then 3x times 2 be plus 6x. Then we have k in the next part. K times 3x be another 3kx. Then I need to make more room. Okay. Then we have k times k be plus k squared. Then we have k times 2 be plus 2k. Then we need to do the same for 2, and I need more room again to the left, if it lets me. I don't know if it will it. I don't know. Oh. Oh dear. Oh, there we are. Okay. So then 2, sorry, times by everything in the other bracket. So 2 times 3x plus 6x. Then 2 times k will be plus 2k. Then 2 times 2 will be plus 4. And again, we can simplify this. So firstly, 9x squared, collect the x squared terms. Then we have 3kx. So 3kx and then another 3kx be 6kx. Then we have 6x and then another 6x plus 12x. Then we have k squared. Then we have a 2k and a 2k plus 4k, and then a plus 4 at the end there. There we are. So now we can substitute that expansion into what we were originally doing there. Okay. Then that would be plus 9x squared plus 6kx plus 12x plus k squared plus 4k plus 4 minus 18 equals 0. Okay, and then again, then I'm going to collect the like terms together. So we have x squared and 9x squared be 10x squared. I can cancel that off. Then have a minus 10x. Then have a plus 12x, that'd be plus 2x overall. Then I have a plus 25. Then I have a plus 4 and a minus 18. Yep, so 25. Add 4, take away 18, gets me plus 11. So I can cancel those off. Then I have a 6kx. That's the only kx term. Then I have a k squared, the only k squared, and then 4k. Cool, and then that's equal to 0. Okay, then I'm going to group it into a quadratic. So x squared term is just 10x squared. Then the x terms, so we're going to x and then 2 from there, and then a 6k from there. Then let's just add the numbers together. So we're going to have k squared at 4k add 11 equal to 0. Okay. So there, okay, that's a quadratic. Now again, one intersection then, because it's a tangent, means the discriminant has to equal 0 in that case. Okay, which is a lot nicer because now we won't have an inequality. Anyway, so the discriminant then in that case is going to equal 0. So b squared there be 6k plus 2 all squared minus 4 lots of a, which is 10. And then this whole c, this whole number bit at the end, k squared plus 4k plus 11 has to be equal to 0. Then I just need to expand these brackets again. So 6k times 6k be 36k squared, then 6k times 2 be 12k, and then another 12k be 24k. Then 2 squared is 4. Then minus 4 times 10 be minus 40 of k squared plus 4k plus 11 equal to 0. Then 36k squared plus 24k plus 4. Then I'm going to expand it, so minus 40k squared. Then minus 40 times 4 will be minus 160k. Then minus 40 times 11 gets me minus 440 equal to 0. And there we are. Then I'll collect the terms together. So 36k squared minus 40k squared be minus 4k squared. Then 24k minus 160, where 24 take away 160 equals minus 136k. Then we have plus 4 minus 440 gets me minus 436 equals to 0. Can I simplify it a little bit? I can. Everything divides by minus 4. Therefore, we're going to get k squared, then minus 136 divided by minus 4 gets me plus 34k. Then minus 436 divided by minus 4 gets me positive 109 equal to 0. Okay, cool. Okay, well then I'm going to solve by the formula. Say, quite big numbers to do it any other way. I'll just use the formula, nice and easy. So that being minus 34 plus or minus the square root of 34 squared, minus 4 lots of a, which is 1 and 109, over 2 lots of 1, and that'll give me my 2 solutions for k. And that would equal okay, so k would be minus 17 plus or minus 6 root 5. Okay, there we are. And it says find the possible values of a, give me answer as simplified surds. Okay, there we are. Well, those are answers then. These are the two answers in as surds. So you could say then k is minus 17 plus root 6 plus 6 root 5, sorry, or k is minus 17 minus 6.5. And those are my two solutions for k. There we are. Oh man. So yeah. So I mean, conceptually, I don't think it's that much of a step up to what we've done, but you really need to know your algebra, right? There's a lot of lot of crazy bracket expansions. You need to solve equations. You need to get a quadratic equation that looks weird, you know, to use a discriminant onto it, and you need to know how to solve inequalities and so on. So it's a lot of simple ideas, all get stockpiled into one, really. So yeah, you need to again make sure you're comfortable with your algebra skills here. But once you do, these questions aren't too bad. Really, it's the same sort of idea every time. Okay. Final question then. A sort of a challenge, harder step up question. So final exam question here. We are told a circle with radius r lies only on the first quadrant and touches the x-axis and touches the y-axis. The line out was equation 2x plus y is 12. Find the x coordinate of the points of intersection L and C that satisfies this equation. Show that this equation holds when they intersect. So again, we need to get an equation of the circle and the line. Well, the line is 2x plus y equals 12, okay? But we need to find the equation of the circle. But they haven't told us at this time. But we need to work with what we're given here. And again, this is sort of a geometric problem that we looked at last time. And again, you should sketch sketch the scenario. So if you have the graph, the grid here, x, y. Well, we are told it firstly lies on the first quadrant. That means that it's here in this quadrant, right? The XY grid is split into 4 quadrants. We call this one the first, this one the second, this one the third, and that one the fourth, just so you know. So the first one means we're working on positive x and y, essentially. So it's here somewhere, okay? What we're also told then is that it touches the x-axis and touches the y-axis. That means then, wherever we put our circle, say here, for instance, if it touches the x and the y-axis, it's just going to cross it once. So the edge of the circle is going to be on the y-axis there, and the edge of the x-axis is going to be there. Then we can sort of picture the other edge points of the circle to be there and there somewhere. Then if we sketched it, it would look like that. Okay, a bit of an awkward one, but the circle then, you can see it touches the y and the x-axis, okay? So again, how would we then start to, so again, our circle is going to be x minus a squared, and y minus b all squared, equals r squared. Well, the total the radius r is r, okay? So we need to work out the centre then. How would we work out the centre then, AB, in this situation? Well, again, think about the centre. Think about what the x and the y coordinate would be. Well, it goes straight down there, straight there. Well, isn't the distance here the radius r? Because if it's touching, that means the x-axis is the circle. The point on the circle is also on the x-axis, so that would be the radius r joining the centre to that point on the x-axis, wherever that is. Likewise on y, if it's on the y-axis, that means the circle is the edge of the circle. The circumference is also on the y-axis, so it's a distance of r from the centre. Okay, well then that means then that this point, surely the x value would be r and the y value would be r. So then it would be r for the centre in this case. So if centre then is r and r, therefore we get x minus a, where a be minus r. Because if it's positive r, it'd be then minus r all squared. Then y minus b, well, it'd be minus r again, all squared, equals r squared, okay? And that is my centre. Cool. So see there, the whole idea about sketching what you're given, really helps there, and also to consider the radius, right? So consider drawing a radius to these points, and hopefully then you can visualize that the center indeed would be RR in this case there. Okay, there we are. So now we've got an equation, right? It's not the nicest because we've got an R in there, but this is equation 1, and now this line will be equation 2. And by the way, I know I can't simplify anything more because I can't then somehow find the radius, because our answer wants the radius R in the answer, so we can't get rid of it just at the moment. So this is a simple. That's as much information we can work out. So right at the centre, there we are. So now again we need to then. So again we then need to substitute the line here into the other equation there, but again I need to rearrange it. So then y, so if I rearrange the second equation, I get y is 12 take away 2x. Therefore if I sub y into the circle equation now, I then get that x minus r squared, add y, now y would be 12 take away 2x, then minus r all squared, and then I'm going to take away the r squared equals 0. Okay. Okay, I need to expand it then. I'll have to expand it because you notice the in the question here it's written as a quadratic in x. Okay. There's no brackets, no squared brackets or anything, so I do need to expand. So let's do it then. So x minus r, well, it'll be x squared times x times minus r being minus rx, then another minus rx being minus 2rx plus r squared. Again, if you're struggling with that, I know the algebra might be a bit weird. Again, do it step by step on somewhere else on the paper, right? And then expand that step by step. Anyway, we get that then at the end. Then I'm going to do, and then I need to expand this. Okay, well again, that I am going to do somewhere else separately, because that's an awkward bracket. I'm going to do that. Where am I going to do that? Tell you what, r squared. I'll do that. I'll do that here. I don't know why I'm overthinking this. So we have 12 take away 2x take away r times by 12 take away 2x take away r. So if we were to expand it, again, 12 times 12 be 144. Then 12 times minus 2x be minus 24x. Then 12 times minus r being minus 12r. Then we move on to the 2x. So 2x times 12 be again minus 24x. Then we have minus 2x times minus 2x plus 4x squared. Then we have minus 2x times minus r be plus 2xr or 2rx. Then we have then we lastly deal with the r term here. So then minus r times 12 be minus 12r. Then minus r times minus 2x be plus 2rx. Then we have minus r times minus r be plus r squared. Then I can simplify it. So then we have 144. Okay, then minus 24x be minus 48x. So I can get rid of those. Then I have minus 12r, another minus 12r be minus 24r. Then I have 4x squared. Then I have 2rx, another 2rx be 4rx. Then I have an r squared at the end. Cool. So now I can substitute that in into here, but now I've not made enough room. So I'm going to do that. So I'm going to do that down there somewhere. Okay. I'll do it down here, away from the working. So if I then expand all these brackets, right, I've already done the first part, x squared minus 2rx plus r squared. Then I'm gonna oh god, then I'm gonna add these terms in from this bracket there. So that will get me then plus 144 plus 1. Oh god, plus 144 minus 48x minus 24r plus 4x squared plus 4rx plus r squared, and then a minus r squared at the end equal to 0. Okay. Then I need to collect the like terms. I have an x squared here and a 4x squared there, it'd be 5x squared. Then cancel that out. Then I'm left with 2rx minus 2rx, and then a plus 4rx will be plus 2rx overall. Then I have r squared here, but I'm gonna deal with the x. I'm gonna include the x part. I want to get the other x terms first, right? So I have 48 minus 48x there, and that's really it. Then I could deal with the r squared, and then have another r squared there. 2r squared take away r squared is again just r squared afterwards. Then I have plus 144. Then lastly I have minus 24. Oh god. Minus 24r equal to 0. And there we are. So then lastly, if we group all the x parts together to make it a quadratic, we're going to get 5x squared, then the x parts, so we're going to get x of 2r here, and minus 48 there. Then lastly, we group the numbers at the end together, we're going to get r squared, and then I'm going to do minus 24r plus 144 equal to 0. Okay, that's what I get in the end. Does that match what they're giving me? 5x squared, 2r minus 48. Yep. And then r squared minus 24r plus 144. There we are. Okay, we got there. That is very nasty. Only 3 marks, that is, but we have to do it. There we are. Okay, so that's the equation we should get then, so we're on the right track. Then part B then, it says, given also that L is a tangent to C, find the 2 possible values of R. Give me answers, sir. So again, if it's a tangent, that means one intersection between the line and the circle, which therefore means the discriminant has to be equal to 0 to give one root, or a distinct root. Okay, so there we are then. So then we need to consider the discriminant. So the discriminant, as we just discussed has to be equal to 0 as it's a tangent, meaning one intersection. If we do that, but then b there be 2r minus 48 all squared, take away 4 lots of a, which is 5. Then we have this whole number at the end of r squared minus 24r plus 144 has to be equal to 0. Oh, I didn't mean to do that. Plus r squared. There we are. Okay. Okay, then we just need to expand the bracket. So this bracket, so 2r times 2r, but then before r squared. Then 2r times minus 48 would be 2 times minus 48 would be minus 96r, but then another minus 96r would be minus 192r. Then minus 48 squared would be 2304. Then we do minus 4 times 5 is minus 20 of r squared minus 24r plus 144 equal to 0. Okay, then if we expand that, we get 4r squared minus 192r plus 2304, take away 20r squared, then times minus 20 by minus 24, I get plus 480r. And then minus 20 times 144, I get minus 2880 equal to 0. Then I need to then collect the like terms. So 4r squared minus 20, that being minus 16r squared. We can cancel that out. Then we have minus 192r, and then plus 480r. So 192 add 480 gets me plus 288r. Then we add the numbers, so we're gonna get 2304 take away 2880. We will get minus 576 equal to 0. Okay. And we can simplify that again. 16 goes into all the terms. So divide by minus 16, we would get r squared. Then 288 divided by minus 16 gets me minus 18r. And then minus 576 divided by minus 16 gets me plus 36 equal to 0. There we are then. Okay, so then I'm going to just solve it by the formula again. So I is going to be plus or minus the square root of, no, sorry, I jumped the gun there. Plus 18, minus 18, plus 18, plus or minus square root of minus 18 all squared, minus 4 lots of 1 of 36, all over 2 lots of 1, and that would give me the solutions. 1 minus 18 and 36 of 9 plus or minus 3 root 5. Okay, so those are the two solutions for r then. Okay, we got there. There we are, two values of r. Give me answer as fully simplified surds. They are fully simplified. The calculator will always give you the fully simplified version of a surd if you put it in. Okay, so therefore our two solutions then is r is 9 plus 3 root 5, or r is 9 minus 3 root 5. And those are two solutions. And that's it, those are the examples then. So it can get pretty nasty, you know, the exam questions. But the idea is mainly the same. You just got to do more expansion. Okay, so the idea is the same. Sub the line equation into the circle. Then you need to expand all the brackets to get a quadratic in the end. Then you probably will need to use a discriminant. Use b squared minus 4ac to find a missing number. So that could be k, that could be r, like in the last instance, and therefore there you are. Okay, but it's a lot easier saying it here than obviously doing it. There's a lot of algebra you have to sift through. So yeah, so that's intersections with straight lines and circles. So yeah, I'll see you next time.